Welcome to the Fundamentals of Refrigeration and Air Conditioning course. I'm Dr. Sam Taufik, and I will guide you through the essential concepts in this important field. Trainer Biography. I'm Dr. Sam Taufik, a seasoned expert in refrigeration and air conditioning. I have years of hands-on experience and a PhD from the University of Alexandria. My career has included designing, building, and maintaining various refrigeration systems. I've worked on projects such as residential cooling systems and sized refrigeration systems for marine applications. I'm excited to share my knowledge with you and help you understand the complexities of refrigeration technology. Contacts. Here are my contact details. You can reach me via mobile or WhatsApp at +201 001808616 or email me at sama_taufik@hotmail.com. Additionally, you can check out my YouTube channel for more resources at Dr. Sam Taufik. Course information. This course is designed to provide you with a solid foundation in the principles and practices of refrigeration and air conditioning. By the end of this course, you will understand the different components of these systems, their functions, and how they work together to create efficient cooling solutions. Course objectives. Upon completion of this course, you will be able to identify the basic components of refrigeration and air conditioning systems, understand their functions, and recognize various refrigerants. You will also learn about the engineering principles that guide their design and operation, as well as the importance of safety and quality control in the industry. Lecture objectives. In today's lecture, we will provide an overview of the basic thermodynamic concepts necessary for refrigeration science, introduce the tables and charts commonly used in refrigeration analysis. Basic principles of refrigeration. Let's start with the basic principles of refrigeration, which are rooted in thermodynamics. Understanding these principles is essential for grasping how refrigeration systems operate. Phases of matter. We will now discuss the phases of matter: solid, liquid, and gas. Each phase has distinct properties that affect how substances interact with heat, which is crucial for refrigeration application. Structure and differences between phases. The structure of different phases varies significantly. For example, solids have tightly packed particles, while gases have particles that are more spread out. This structural difference influences how heat is transferred and how substances change state. How to convert between phases. To convert between phases, energy must be added or removed. For instance, heating ice causes it to melt into water, while cooling water can freeze it into ice. This phase change is fundamental to refrigeration processes. What is heat? Heat is a form of energy known as thermal energy. It is the energy that causes an increase in the temperature of an object and is essential for understanding how refrigeration works. What is temperature? Temperature is a measure of thermal energy. It indicates how hot or cold a substance is and plays a crucial role in determining how heat transfer occurs within refrigeration systems. The difference between heat and temperature. It is important to distinguish between heat and temperature. Heat refers to the energy transferred between substances, while temperature measures the intensity of that energy. Understanding this difference is vital in refrigeration. Definition of refrigeration. Refrigeration is defined as the transfer of heat from one location to another through a change in the state of a liquid. This process is essential for creating cooling effects in various applications. Example of evaporation. An example of refrigeration is how alcohol evaporates and cools. As it changes from a liquid to a gas, it absorbs heat, creating a cooling effect. Sensible heat. Sensible heat is the energy that causes a change in temperature of a substance without changing its phase. This heat can be measured with a thermometer and is important for managing temperature in refrigeration systems. More on sensible heat. As mentioned earlier, sensible heat affects temperature, but not the phase of the substance. Understanding how to manage this heat is essential for efficient refrigeration operation. Latent heat. Latent heat is the energy absorbed or released during a phase change without a change in temperature. Unlike sensible heat, it cannot be measured directly with a thermometer. Refrigeration process. The refrigeration process involves reducing heat energy. For example, cooling water from 12 degrees C to 6 degrees C involves removing sensible heat, while changing water at 0 degrees C to ice at 0 degrees C involves removing latent heat. Refrigeration tables and charts. To effectively solve refrigeration problems, we use specific tables and charts. These resources provide critical parameters for analyzing refrigeration cycles and allow for accurate calculation. Example of refrigeration charts. Each type of refrigerant has its own unique tables and charts. Familiarity with these tools is essential for anyone working in refrigeration and air conditioning. Thank you for your attention. I hope this lecture has provided you with a clear introduction to refrigeration concepts. I look forward to our next session, where we will delve deeper into these topics. With my best regards, Dr. Sam at Tawfiq.